All right, ladies and gentlemen, so if we're going to do, you need to know stuff about tangent when we do the unit circle. If you notice the chart on 5.4, the only denominators I have are fours and twos, right? So I didn't do sixes or threes or anything like that. So I'm not asking you to remember them, but remember that tangent isn't obvious on the unit circle. You have to do some math to find it. So when I did the division here at pi over 6, my tangent was 1 over root 3. And when I did my division here for tan at pi over 3, it's just root 3. So remember that tan is sine divided by cosine, okay? Everybody knows that. So just looking at the unit circle, it's not obvious, but you can calculate what tan is. So at pi over 4, root 2 over 2 divided by root 2 over 2 seems like a difficult thing to divide, but if they're the exact same thing, tan has a value of 1. Okay, so let's move up to pi over 2. Pi over 2, what is tan at pi over 2? Okay, so this would be sine over cosine. What's happening there? It's undefined because we can't have a denominator of 0, right? So on the tan graph, we're going to call that undefined. And what that's going to turn into is an asymptote for that graph. Okay, so again, I'm going over here. I'm going to 3 pi over 4 is my next spot. What's tan value here? Negative 1. And at pi, it's 0. Oh, look at that. Tan theta equals 0 because it's 0 over negative 1. So that has a value of 0. I'm going to come down to 5 pi over 4. 1. Positive 1. And 3 pi over 2. Undefined. I'm just going to call it UD so that you guys know that that's undefined. 7 pi over 4. Negative 1. And then 2 pi or 0, depending on where you are. 0. It's going to be 0 again because it's going to be 0 over 1. Okay? So using if you know your unit circle, you can find your tan values. But the undefines kind of mess people up because there's a 0 in it, and it does matter if the 0 is on top or if it's on bottom. Okay, so that is my pop quiz. And we're going back to this. And I'm not super zoomed in on this because it's such a big table, but you really do need to see all of this. So let's start at the positive portion of our table. Let's start here. So at 0 radians, what's the value of tan? 0. Pi over 4. Positive 1. Pi over 2. Undefined. 3 pi over 4. Negative 1. Pi. 0. Pi over 4. Positive 1. 3 pi over 2. Undefined. 7 pi over 4. Negative 1. And 2 pi. 0. Okay, so you see that pattern coming back again, right? This one isn't a sinusoidal wave, but it does something really cool. Okay, so let's go backwards. Okay, so let's look at the pattern. Negative 1, 0, 1, undefined. So undefined frames, 3 values, right? So as long as we're going up by the same increments, this should be good. So if it's positive 1, 0, what's this one going to be? Negative 1. And it's a quarter pi, so that's going to be, like if this were the unit circle, negative quarter pi would be in quadrant 4. What's up? Negative pi over 2, which would be here. So that's undefined. And so is the table much easier to fill in when you see the pattern? Okay, so this one's going to be 1, 0, negative 1, undefined, 1, 0. All right, I'm going to zoom in now. Oh, that's not good. That's really not good. It's not focusing. Okay. All right. So let's talk about my increments. First of all, what's my period? Can you tell from the table? Okay. All right. Okay, let's go up by quarter pies. That would make the most sense. Everybody with me on that one? So quarter pies. So yes, but this one's a little bit different because it's not a sinusoidal function. Oh, guys, I didn't give you enough room. That's okay, though. Just draw more of the lines. That's a pretty straight line for me, I'm just saying. 5 pi over 4, so it will be 3 pi over 2, and then I'm going to have 7 pi over 4, and I'm going to have 2 pi. Maybe I'll just stop there because I'm going to run into the table. Is everybody okay with that? All right. Now we're going to graph this one. Okay, what's happening at 0? Let's just start with 0. It's just easier. Something's happening at 0. What's happening at 0? 0. Good job, everybody. What's happening at pi over 4? 1. What's happening at pi over 2? Asymptote. Okay, let's talk about asymptotes before people start having a breakdown. So, okay, what's an asymptote? Your function can't touch it. It can come close to it, but it can never touch it or cross it. And they are boundaries. They're not actual parts of the function, so they must be drawn on with a dashed line. Okay, because they're not part of the tan function. We're just putting them on so you can see the boundary of it. Okay, exciting stuff. How do we feel about that? Okay, all right. Just as good as I thought we would. 3 pi over 4, -1, pi, 0, 5 pi over 4, +1. Oh, that's a really high +1, sorry. 3 pi over 2, asymptote. So anywhere that the tan is undefined, that results in an asymptote when we're graphing it. 7 pi over 4, -1, and 2 pi is at 0. So it doesn't follow the same wave because it's got these breaks in it. So it can't have the same wave pattern as the sine and the cosine graph. So let's go backwards now. So negative pi over 4, -1. Negative pi over 2, asymptote. And again, I just want to say it one more time. Asymptotes need to be drawn with a dashed line. Negative 3 pi over 2. How come I missed something here, guys? What did I miss? Oh, this should have been 3 pi over 4, not 3 pi over 2. Oh, I was like, something's very wrong with my numbers. There we go. Negative 3 pi over 4, that's going to be a +1. Negative pi is going to be a 0. Negative 5 pi over 4 is going to be a -1. All right, so this is kind of the thing. it's going to be kind of like a cubic function, which you've never graphed yet. So, yet.
Do we have those tangent lines that curve upwards?
So it kind of drags through the middle, and then goes down, and it's going to keep approaching. Okay. Why? Okay, but our sinusoidal graphs, I said your arrows have to point in the right direction where your graph goes next. What's going to happen to this graph? These are going to keep going and going and going. It's going to get closer to the asymptote, but it's never going to touch it. This does not follow the same image, the sinusoidal, that wave that cosine and sine do. That's why we do all the cosine sine stuff first, and then we kind of teach tangent as like a different beast. Yes, Danica? Oh, okay. All right, connect all your lines, guys. Try to make these as. Oh. Okay, you don't want to curve it in all different directions. Remember that it should be pointing towards your asymptotes, like it should be headed towards your asymptotes, but it should never touch or cross your asymptotes. Yeah. I'm awful, or your graphs are awful? Could be a little of both today. Okay. Basil, sometimes you say it in different words. Ouch.
I don't know how to do this.
Okay. Okay, it can't be a straight line. That's going to be the problem, is it can't be a straight line.
Between the three dots, can it be a straight line?
No, it should have a little bit of a wave to it, but we're working on it. We're just starting. You guys did it. This is your first time. It's good to try.
Where should you start?
It probably shouldn't have waves through it the whole thing because, okay. And the reason why is if you guys do root 3, like if I go root 3, that has a decimal value of 1.73. Hang on, I'm working on it. I'll pull this down in 2 seconds. Because what do we know? We know that pi over 6 is less than pi over 4, right? On the unit circle? Yeah? Pi over 6 is 30 degrees, pi over 4 is 45. So this has to be, like that's going to have a tan value at pi over 6 of 1 over root 3, which is 0.58. So your value here, when it's broken down into thirds, should be at about halfway, a little bit more than halfway. But I mean, honestly, guys, we never graph the pi's over 6s and pi's over 3s. But just to give you an idea, and then at pi over 3, which is greater than pi over 4, you should be at almost 1.75. You have other points. You guys know that at pi over 6, the y value is going to be 5.8. You know that at pi over 3, the y value is going to be 1.73. You know that. So your graph should follow that pattern. We're just not going to graph all of those because that's going to be painful. More painful than this. Right now you have 3 dots to go through. Okay. As long as it has this general shape, it's rising to the right and it's falling to the left. And it's not a straight line. Okay? Not looking for perfection the first time. Okay, can I have an amplitude if I don't have a wave? No. Could I have a vertical stretch? Sure, I can. Would we refer to it as an amplitude? Sometimes we do just because they're all trig functions, but just know that it technically doesn't fall under the definition of what a true amplitude is. Period of this function.
Can we say it if it crosses over the asymptote?
It cannot cross over the asymptotes. It's pi. Because that is the boundaries. I have median. Well, I don't have a maximum because it goes on forever, and I don't have a minimum. So, but it continues, this pattern repeats every pi. Because you don't have a max anymore.
So are you just by looking at the graph every single time?
Look between your asymptotes. Okay, domain.
How would you do that for negative infinity to positive infinity?
Except for the asymptotes. So here's the thing, so Amber's on the right track. I definitely would do negative infinity to positive infinity, just to say this is the general one, but I would add a restriction to it, because where does it not exist? Everywhere there's an asymptote, right? So it's everything except everywhere there's an asymptote. Okay, so we're going to do this. You guys are not going to like that. How does that feel?
Not the
X is an element of all the real numbers, which means the exact same thing as negative infinity to positive infinity. Okay?
But what about the asymptote?
Now we're going to make a general solution about our asymptotes. So we're going to put a restriction. So X cannot equal, where's our first asymptote? Okay, let's do our very first positive one. Pi over 2. And how often do those asymptotes occur after the first one? Pi.
Plus pi k.
Plus pi k, where k is an element of the integers. Guys, this isn't a stretch. This is stuff you understand. It really is. Yeah.
So what's the difference between the R and the pi, integers and real numbers?
So real numbers would include fractions. They would include decimals, anything like that. So you could have any number, decimal places, but integers mean we're going to add pi's by the whole number. You're going to add 2 pi. You're going to add 3 pi. You're going to add negative 3 pi. You can't add half a rotation. You can't add half a period. So it has to be an integer for the I. Okay, so look at this, ladies and gentlemen. Let's go back up here. You guys said this was my first asymptote. What's the distance between those two asymptotes? Pi. Right? So that's why the pi is here. Okay, let's go on to something easy, something we feel comfortable with, the range.
Negative infinity, positive infinity.
Any restrictions on that one? Can't write XER, what can you write? What variable is it on the range?
What? Why? It was so good like that. Why did you continue? Oh, okay.
You know what I mean? Because we're talking about the range now, so the letter has to change to Y. Okay, zeros of the function. So we're going to do a general solution because this can continue on forever. We start with our first positive 0. 0. So the zeros occur at 0. When does my next 0 occur? So we are going to add pi k, where k is an element of the integers. Integers just mean we're dealing in whole numbers, both positive and negative, so that because you can't add half a pi and be at a 0.
If you were to do R, that would be saying
That would be any fraction, which would be bad, oh bad, which wouldn't get you to where you want to be. So, ladies and gentlemen, you might see it written like that. Pi k. Because where are you starting? 0. So sometimes in answer keys we won't put that 0, but it means the same thing. You would not be wrong to have the 0 there. Okay, y-intercepts. 0. Asymptotes. You already wrote the general solution for the asymptotes. But what am I going to take out, Basil? Trick question.
The x equals?
It's the can't equals that I'm going to take out.
Oh.
Does that make sense to everybody? Because this time I'm talking about, hey, where are the asymptotes? So now the asymptotes are here.
Can we please not do the reciprocal graph?
Wow, guys. Wow.
Like, that was a lot.
I feel like maybe we could just do one.
Guys, let's do it. I need a
Let's just get one.
let's do it.
Let's just do it.
I'm kind of curious what they're saying.
break my life.
Okay, it's going to be great. Okay. All right. So what you need to know is my first line there. All 6 trig graphs are fair game. Okay? That means I can put them on tests, quizzes, exams. Be ready for any of them.
On any chapter?
Well, I mean, obviously, I'm not going to throw it. I'm not going to do that to you. I'm not going to do chapter 3 and then throw a trig graph. But when you get your test for this, you need to be able to graph all 6 trig graphs.
Okay.
Okay? You have 3 done right now. You're really good at 2 of them. Okay, you're really good at 2 of them. You just learned the 3rd one. Not as comfortable because it's different. And now we're going to do these 3 others. There will be definitely a trig graph on your exam for sure. I just don't know which one yet.
Please put a sign.
No, chances are it's not going to be sine or cosine. I love you all, but not that much. Okay, I do love you that much. That wasn't right. I love you guys very much, but I know you are more talented than just doing the basic graph.
I vote that we do no tan, just the cosine. I mean, the cosecant.
Because I like seeing it. It's my favorite part of the day. Okay, so what I've done is you guys know that cosecant is the reciprocal of sine, right? Okay, so let's talk about what reciprocal means. Flip it. So I gave you the filled in sine chart. I know, so at negative 2 pi, I'm at 0. So on a cosecant graph, if I flip this, what happens? 0 goes on the bottom, and that becomes undefined.
Not more asymptotes, God.
Because that's like saying 0 over 1, and if we flip it, it would be 1 over 0, which would then give us an asymptote. Okay, what's the reciprocal of 1? 1. Good job, everybody. What's the reciprocal of 0?
Undefined.
What's the reciprocal of negative 1?
Negative 1.
Oh my god.
I love you guys.
I hope there won't be any rude waves in this one.
There's going to be a whole bunch of parabolas.
That, I can work with that.
You can work with that? Okay. Okay. All right. Okay, so if we can work with parabolas.
This is quadratic. Let's do it.
Okay. So what am I going to do here? I'm going to do pi. Do 2 pi. 3 pi over 2. Pi over 2.
Why is there no lines on these notes, Miss Gallion? Like for the graphs?
Oh, I didn't feel to be tied down by a grid system. No,
Oh. You just chose not to?
I chose not to.
Okay.
Even, wow. Wow.
Brings us pie.
Do you know, yeah, like I brought you pie today. You guys get all your notes printed for you and handed out to you. And all of a sudden I'm an evil person because I didn't put lines on the graph. You guys are harsh. Hard to please. Hard to please. Okay.
Was that Cameron?
Okay, can we... It hurts, eh? Like every once in a while it hurts. You
It
let...
doesn't hurt, no.
No?
It doesn't hurt.
Okay,
We're not
sorry.
at the same level, yeah, no.
Okay, alright. Are you guys okay if I put my asymptotes on first?
Yeah.
Just because I have my ruler and I just want to do them all at once. So 2 pi is my first one. Pi is my second one. Actually, I'm working back up the charts. 0, 0, negative pi, and then negative 2 pi. All right. Now we could graph more points, but I'm hoping you're going to have faith in what I'm about to show you. I love it. No faith. Okay, perfect. Okay, let's start at the positive. So I'm starting here. So at pi over 2, where am I? 1. So, and then the next place I'm going to be is at negative 1 here. Okay, you guys ready? Oh, so it doesn't look like there's enough points to do anything with, right? And there really isn't until you know a little bit about it. So let's pick some points in between 0 and pi over 2. Pi over 4, good one, good pick. Pi over 4, and shall we do 3 pi over 4? Okay. So, you know that sine of pi over 4 is root 2 over 2. And if I do that in my calculator, that gives me a value of 0.71.
Can we do typical though?
Right. So now we know that about sine, right? So now we need to do cosecant of it. So we know cosecant of pi over 4 is equal to 1 over 0.71.
Why can't we just do 2 over root 2?
Okay, or you can do that. Is that better for you?
Oh, no, okay, sorry. I thought that was like the only way to do it. Okay.
No. I'm just trying to show all my steps so that everybody sees what's going on. Okay, everybody with me so far? So we know that at pi over 4, we're going to be at 1.4. So what do we know sine is at 3 pi over 4? You're in quadrant 2. It's going to be the exact same thing. So what do we know cosecant at 3 pi over 4 is? The exact same thing. I just explained why. Look at your unit circle. Where's sine? What is sine at 3 pi over 4? Okay, so this ends up doing this. All right, so now in the other quadrant, now we're in quadrants 3 and quadrants 4, so if I pick 5 pi over 4, and I pick 7 pi over 4, we know that sine in quadrant 3 is going to be negative root 2 over 2, which would make cosecant at 5 pi over 4 negative 1.41. And the same would be here. All right, So knowing all of that,
So usually we're just supposed to do without the 1.41?
you don't have, yeah, once you know that, you're good to do what I just did there.
Yeah, if you figure out the first parabola with like the delta,
Yeah,
you just copy the pattern and everything else.
100%. Here's the thing though, this is going to be on a non-calculator portion.
What?
Well, we were in the calculator, it's just parabola.
Are we gonna be doing stations in inverse graphs as well?
We don't do a ton, but yeah, a little bit.
What do you mean there's no calculator?
There's no calculator.
How am I supposed to calculate 1 over 0.7
Well, we don't have to.
But you don't have to. You can just do them like this. What I know, this is what I know, is when I'm at a positive 1, which way does my parabola open? Up. When I'm at a negative 1, which way does my parabola open? Yeah. I mean, if you want to get more technical, then you'll have to commit that to memory, because this is most likely going to be on a non-calculator portion of your test. Okay. All right. You're going to love this. All right. Reciprocal, no. Cosecant. We're on, so this is for the cosecant graph. Ooh, these should be on the next page. Okay. Is there an amplitude to this graph?
No.
Right, there's no wave, so there's no amplitude. Can I have a vertical stretch though? Yes, I can. Okay, period. So on the tan graphs, we said look between the asymptotes. Yeah, but no. And I totally get it, because the advice I gave you for tan, it is pi in between the asymptotes, 100%. But does this one look exactly the same as what's happening here? No. This one opens up, this one opens down.
So how would that impact the period?
Because it's going to be pi here, pi here. When does the pattern restart? It's 2 pi. So in tan, the pattern restarted after pi, but the pattern, when's the next time we see an up parabola? Not until this one. So we have to go a pi here, then a pi here, and then we restart again. Does that make sense to everybody? So the pattern repeats, so the period is 2 pi. Okay, domain. Everywhere except asymptotes. So domain is XER. You are totally 100% okay if you want to put it as negative infinity to positive infinity. And now we do the restriction of the asymptotes. So what's the restriction of the asymptotes? X cannot equal, where's my very first asymptote?
0.
It's at 0. Plus, yes.
K is an element of all.
Beautiful. Okay, let's talk about range.
Oh, wow.
Oh, this one isn't as nice. This one isn't as nice. Because what do you notice? There's a whole section of the graph that has no values in it.
So between -1 and +1, we can't trade. What do we do? I don't know. Negative infinity to -1 and 1 to positive infinity?
Okay, so you could do an exclusion, or you could do 2 statements if you wanted to about the range. So let's do 2 statements about the range. Let's talk the lower part of it. Negative infinity to -1, inclusive or not inclusive? Inclusive. And then let's talk about the upper part. Where does it start?
1.
And goes to? Inclusive of 1 all the way to infinity. And then we put the in unison, that little u in between them, because that says these 2 things are happening on the same graph. There's many ways to write this. This is probably just the easiest one. This is nice. None. Y-intercepts. None, because we have an asymptote on the y-axis. Asymptotes, you already wrote the statement.
So when do we use KBR or XER? Is that for?
XER is this. That's XER. Those two things mean the exact same thing. Okay, we're going to be done.